All right, so this is our walkthrough for the homework assignment titled Derivatives of Inverse Functions. So this was our last rule that we needed to learn with derivatives. I'm going to put the rule up here just to start off with. The rule is that if f and g are inverses, and f contains the point AB, which we should know means g contains the point B, comma A, then f prime of A is equal to 1 over g prime of B. Right? That's our rule. So what we're looking for here is g prime of 3. Well, that means that g, in this case, is going to contain a point 3, comma, something. Whereas f is going to contain a point something, comma 3, because they are inverse functions of each other. So if we want g prime of 3, it should be 1 over f prime of whatever number goes in right here as the x value for f. Well, in order to figure that out, we just need to set f of x, which is 1 over x, equal to 3. So we should be able to really quickly just solve that and say, well, that's the case when x is equal to 1/3. Okay? And so now we know that when x is 1/3, that's the x value of this point, and that's the y value of this point. And so we should just now be able to use this formula that f prime of our a value, which is 1/3, should equal 1 over g prime of 3. Or in other words, g prime of 3 should be 1 over f prime of 1/3. So we'll write that. G prime of 3 should be 1 over f prime of 1/3 if we just cross multiply there. So then all we have to do is find f prime of 1/3. Well, f prime of x is the derivative of 1 over x. And 1 over x's derivative, you can either use the reciprocal rule for that if you want, or you can just think about it as f is equal to x to the negative 1. So its derivative should be negative 1 x to the negative 2, or negative 1 over x squared. So if we look for f prime of 1/3, that should be negative 1 over 1/3 squared. Well, 1/3 squared is 1/9, and negative 1 over 1/9 should just be negative 9. So now we know that f prime of 1/3 is negative 9, so g prime of 3 should be the reciprocal of that, or negative 1/9. So we're going to use the same idea here. We have h is the inverse function of g, and we have the function for g of x is 2x plus 3. We want h prime of negative 5, which means that h must have a point negative 5 something, which means that g, its inverse, has a point something negative 5. So in order to figure out the answer to this, we just need to figure out what that x value is for g. So we'll set 2x plus 3 equal to negative 5, and when we do that, we should see that that gives us a value of x is equal to, 2x plus 3. We should see that that gives us an x value of negative 4. And if we subtract the 3, we get negative 8, and divide by 2. So that means this is a negative 4 here. And so if we want to find h prime of negative 5, it should just be equal to 1 over g prime of negative 4. Now, in this instance, g prime of x didn't really matter what that value was, because g prime of x is just 2, right? And so g prime of negative 4 must also just be 2. So this ends up being 1/2. Now, our last couple here are going to be a little bit trickier. These are ones that have something similar to this has shown up on the AP test in the past, where we have a function like 3 plus e to the 3x. And we know that g and f are inverses of each other. And we know that 0, 4 is on the graph of f. So we want to find g prime of 4. Right? Well, if I know that f contains the point 0, 4, and g contains the point 4, 0, and I want g prime of 4, it must just be 1 over f prime of 0. Well, if we look at f of x, we should be able to find f prime of x, right? The derivative of 3, that's the derivative of a constant, so that's 0. Then we just need the derivative of e to the 3x. Well, if we think about e to the 3x, that's e to the u, where u is 3x, that's just the chain rule. So the derivative is e to the u and multiplied by 3. So 3e to the 3x. So if we evaluate f prime of 0, that's 3e to the 0, which is just 3, which means that our final answer here is just 1/3. And our last one here is pretty much the exact same question here. We've got f of x is 4 plus e to the 4x. And we've got g and f are inverses of each other. And so if we know that's true, then we should just be able to use that same idea, right? We should be able to just say, well, if f contains 0, 5, then g contains 5, 0, and g prime of 5 ought to equal 1 over f prime of 0. And f of x is just 4 plus e to the 4x, so f prime is just going to be 4e to the 4x, using that same idea with the chain rule. We'll write it out though, e to the u, where u is 4x. And so it's e to the u times 4. And then if we want to find f prime of 0, we'll just plug 0 in and get 4. So our final answer here is just 1/4. And that's it for our derivatives of inverse functions homework walkthrough here. Fairly straightforward one, I hope. And there's going to be another assignment with inverse functions. It might be slightly more difficult. So that's it.